Hello again, it's Cliff here from Down Under, and this video is about changing my old Series 1 Tormach over to a Series 3. So I've got the upgrade kit. I actually bought it when I brought in Rapid Turn about a year ago, and I've finally decided I'm not going to run out of work, and I was going to fit it when I ran out of work. I'm not going to run out of work, I just have to stop what I'm doing and fit the upgrade kit. So I've been doing that for the last few hours, and I'll go through that. John Saunders has already produced an excellent YouTube video on the subject, and so rather than me repeat the same footage that he's done, I've put this together to kind of complement his video and try and add to the collective knowledge on the subject of the upgrade of the stepper motors and drivers from Series 1 to a Series 3, and I'll also go over adjusting the thrust bearings of the ball screws at the same time. Alright, cheers. This coupling that connects the stepper motor to the ball screw plays a very key role on low-cost CNC machines. This is just a simple clamp type coupling with two 5mm cap screws providing the grip on the shaft of the motor and the ball screw. And on my coupling there was some pretty poor quality screws used. If I look closely at the screw, it says 8.8, which is a medium grade heat treated carbon steel screw, but I just tested it and I flattened it with a copper hammer onto a piece of mild steel. Where am I? Here. And it damaged the screw rather than the mild steel. So definitely a inferior quality screw compared with an out of the box good quality screw. You can see there it's imprinted into the mild steel but not damaged the screw. So I'll be definitely replacing those cap screws with good quality cap screws. You can also tell the quality of the screw by just looking at it closely. The fit of the hexagon key, the actual outside diameter should be just under 5mm, but this was right down to 4.7mm, and it's stripped out without much effort at all. Now that's really handicapping your ability to correctly tighten the coupling. And what you think may be a problem with lost stepper motor steps may be a skidding or slipping coupling. So it's really worth getting good quality cap screws. Put it in one size longer if you're not getting full depth of thread penetration. Put a tiny amount of anti-scuffing paste on the thread and under the head, because you want your tightening torque to be clamping the coupling on the motor and the ball screw rather than wasting it in friction. But don't put too much lube on there, because you don't want it getting in the bore and affecting the grip of the coupling. When you've got the stepper motor off and you're about to put the new stepper motor on, it's quite a good time to check the preload of the ball screw thrust bearings. If you measure the shaft diameter, you can see it's 12.7, which is ½ inch. Let's have a look on the machine. So here we are, trying to give it a light in there. Okay, so there's our adjusting nuts and the coupling, and in there you can see a short section of diameter. So if you get a ½ inch dowel, you could probably pick that up from an engineering supply shop and clamp it on to the coupling and clamp the coupling onto the ball screw. You can and then snap a vice grip onto the end of that ½ inch dowel. You've now got a right angle permanent connection to the ball screw, and you can put some weights on it and decide how much preload is on those bearings. So that weight is enough to turn the vice grips. Lift it back up, but that weight isn't. So I've got a pretty sensitive measurement of just how much preload is on that thrust bearing before I even start, those thrust bearings before I start. And now I might decide, well, it's a little bit light, I just like to tweak it up slightly more. Actually, in this case, it feels about right, so I probably won't make much of an adjustment. But if it drops down really easily and there's very little friction there, you've probably got virtually no preload on those bearings, and you'll have quite a bit of backlash in your X-axis or whatever axis it is. And then you need to back off that little tab washer and make the adjustment. Now in theory, the inner nut is the adjusting nut, and the outside nut is the lock nut, and the tab washer is bent over to stop it all from coming apart. But in practice, it's not as simple as that. In this sort of application, it's a pretty Mickey Mouse way to make the adjustment, to be honest, because when you tighten up the lock nut, there's clearance on the threads obviously, and it biases the adjustment of the adjusting nut. So, and the tab washer has clearance in the slots and so on. So the whole assembly is pretty variable. So what you're concerned about is the end result. When you've finally finished and nipped it all up, what is the preload like then? You can't sort of measure it a step at a time, because when you tighten up the lock nut, it will transfer that torque through to the adjusting nut and change it again. So just be aware that it's a bit Mickey Mouse, and you're looking at the end result to see how much more or less torque you have applied to those thrust bearings on the end of the ball screw. Just thinking about adjusting the thrust bearings a bit more, what would be better when you've got that little vice grip connector in there is to completely back off the adjustment and then feel how much preload or how much friction is on the ball screw with no thrust bearing preload. So, you know, put a little weight on it, so many ounces of weight, and that is just the ball screw and nut preload, and then begin to adjust up the thrust bearing adjustment until you get additional preload, and then you can separate out the friction from the ball nut and screw from the friction of the preload on the thrust bearings. So check the surface of the box housing is free of lumps of paint and so on before you screw the new stepper motor on, and then tighten up those 4 screws before you tighten up the coupling. Otherwise you'll be putting another preload situation on it if you tighten those up afterwards. Let's just have a look at the coupling now. Okay, put a bit of light on the subject. Okay, how are we looking? Right, so now I've got those better quality, longer screws in there with a little bit of anti-scuffing paste on the threads and under the heads so that I can crank them up really tight, because you don't want them slipping and you don't want the screws stripping. And it's a good idea to align the slot in the coupling with the slot in the ball screw and the flat on the side of the motor shaft. And there's 2 good reasons for doing that. One is, if you ever do get any coupling slipping, you can take the cover off and visually inspect it and see whether or not there's been any rotary displacement. If they're still in line, you know the coupling's not the problem. And the other one is that the slot in the coupling is an area of the coupling that doesn't grip very well, and you might as well put that in an area of the screw and shaft that doesn't have any diameter. Now we want to pull the stepper motor wires through the original conduit. So we connect up the 3 new wires to the 3 old wires. Remember, we want these wires, they don't need to have electrical connection, they need to have tension mechanical connection. So if you wrap it around the wire and then back around itself, and then wrap that wire around and then round itself, it should have a good tension mechanical connection to not come loose halfway through and have a disaster on my hands. And finally, a little bit of insulation tape spiraled round it just to make sure it doesn't snag on any sharp edges as you pull it through. If you ever have a real borderline situation trying to pull it through, you could use heat shrink tubing, which will probably be more secure. So I pulled the wires through in 2 stages to avoid hacking it round any sharp corners, and it came through pretty freely. So at least with these 3 wires on the X and Y, you don't have to have a very fancy mechanical connection. Now I've just got to pull it through into the electrical cabinet there. Yeah, there wasn't much load at all on there. Just a few kilos to pull that through. It may be different on the Z because there's an extra couple of wires for the brake in there. It's probably a good idea to fit the new fittings as they suggest in the little information brochure. Use the new fittings rather than the old fittings in case the thread's different or the seal's been damaged. It's not completely coolant proof though, because when I pulled out the old wire it was slimy with cutting oil anyway, so hopefully that's not a problem. And then finally I'm pulling it into the electrical cabinet. So you can see that the cable that's being replaced, which has got a large heavy duty external insulator, is just 3 light wires with their own insulation. It's not as heavy duty a system. Slightly concerned about the fact that, you know, it isn't as well insulated, but I guess Tormach have gone that way so that it's a slimmer profile and can be more easily retrofitted and pulled through the old conduit tubing, and it's just a practical solution to that problem. If you're really worried about coupling slippage, as I was a few years ago, I noted it was happening on my y-axis. I closed the coupling up until it was slightly tighter than it ever would be, and then drilled and tapped 2 grub screws, and that way I engaged the grub screws onto the motor flat and the ball screw keyway as an additional mechanical coupling so that it would be much less likely to slip. And as far as I know, I haven't had any problems since that was done. When you're doing a job like this, it's always a good idea to check key adjoining screws. These, I think they're M8 cap screws. 2 of them were not very tight on the Y, and on the X 2 of them were virtually loose. There's 4 of them in total though, so it probably isn't a problem on my machine, but it's possible someone out there will have a machine with 4 of the housing screws loose, and this could introduce backlash into that axis, just with this whole box housing moving each time the direction's changed. So now I'm looking at the thrust bearing adjustment of the Z screw. Let's just have a look in here what I'm doing at the moment. See, I've got a dial indicator on the adjusting nut there. That's reasonably concentric, and if I rotate the screw with my vice grips in the top, see if I can show this. Okay, if I push the vice grips in an anti-clockwise direction, you can see the screws rotating there, and the needle's in contact. What's happening is the screw's under tension and it's lifting the head, and I can feel the resistance of the ball nut and the thrust bearings. And then when I come down to contact and the head is contacting on a block of wood, the load comes off the screw, and at that point it's fairly neutral loaded. And then if I continue in the other direction, you can see what's happening there is the screw's going under compression as the head sits on a block of wood, and the thrust bearings are being loaded in the other direction. So if you like, that's the backlash in the thrust bearings directly measured. So that's probably the top thrust bearings under tension, lifting the head's coming down, contacting on the wood. And if I continue, the screw goes under compression and starts to bias the other pair of thrust bearings, and that's the backlash. And it feels more like spring than actual slop, because it sort of moves under load in a sort of slow, soggy way, and that probably can't be adjusted out. That's probably just an inherent feature of that size of thrust bearing, that it's springing that amount, and that's about 2 or 3 hundredths. Obviously, if I gave it a bigger load, it would continue to spring, and that's the whole thrust bearing housing, casting, flexing, and it would continue on. But I wouldn't want to do that because I might start to damage the thrust bearings. I'm just trying to imagine what in use would be the amount of load. But you're talking about a couple of hundredths there of spring. It's about a thou. I'm not sure if that can be improved by tightening the preload or not. Just another little point to note, when you tighten up the cap screws holding the stepper motor down onto this box housing, just double check. Let's get a light on it. And then you, as a second operation, is to tighten up the coupling screws. Just make sure the shaft of the stepper motor is not bearing down on the ball screw shaft. There's a very small gap in mine. I've just checked it with a little bit of wire, of that flat plastic wire, and there's a few thou gaps, so I'm okay. But you know, some of you might find that those two shafts are in contact, and when you tighten up these screws, you'd be putting a massive load on the stepper motor bearings, and that would not be good. So keep an eye on that there's clearance there. If I was doing this again, I'd make a small improvement, so I'll pass it on to you guys. I would put an additional insulating tubing over each group of axis motor wires. The Z-axis has got 5 wires, so I'd probably take the Z-axis down to an electrical supply shop and buy some heat shrink tubing or small diameter tubing that I could pull through, just to give it an additional layer of insulation, and also it would help keeping all the wires together, and it would help with pulling it through the various ragged sharp holes in castings and sheet metal, and lessen the chance of doing damage to the insulation, either on installation or long term. Would have been better if I'd done that, but I'm not going to do it now because I'd have to redo it all. So if you're thinking of doing it, guys, I'd pick up some small diameter insulated tubing that doesn't have a large profile, that you can just slip the Z-axis bunch of wires through, and that way it keeps it all together and gives you a bit more insulation. Okay, now installing the drivers and wiring them up is a little bit complicated, especially if you've got an early Series 1 machine as I have. It would be helpful, I think, if I went over what I've just learnt. So this is a Series 3 to give you a bit of background, and you can see the drivers are all lined up there on the top right hand corner, with the bus board in the top left hand corner. Now, we're not able to do that with the early Series 1 machines. If it's set up like mine, you're a little bit compromised with what you can do. The adapter brackets, that's these brackets here, can go in different ways, but I found that was the best way to fit it in, because it's cramped right over on the left hand side. I found it easier to mount the bracket to the driver first in this case, and then screw the bracket in with cap screws. I tapped out to M4 so that I could use a ball-ended Allen key to put those cap screws in. So okay, that's got that driver in place. Now I'll go over some of the details of wiring. Okay, I'm not an electrician, so forgive my terminology on some of this, but looking at the old driver, this whole block unplugs, and that's the ribbon cable going from the main control board. That can also be unplugged from that block. So this little ribbon plug is unplugged. Put that back for now. And over here you've got a terminal block which holds the two power wires and then the phases for the motor. There's probably 3 phases and an earth there on the old motors. On the new motors it looks like there's just 3 phases and the 2 power wires. So looking at the driver out of the machine for a minute, you can see the wiring coding here on the side and the little dip switch settings. So that's it in place there, and you can't see the coding because it's around the back. So I'm referring to another driver to get my connections. There's good information on the Tormach technical document, but I found I had to sort of read it for 10 minutes and carefully digest it all to see what I'm doing. This is the old terminal block. On the x-axis, these 2 wires, 303 and 302, are the power wires coming into the driver, and the 3 wires, see if I can find them now, these 3 wires, which I'll soon be connecting up, are the 3 phase wires going out of that terminal block to each of the stepper motors. So you just have to think about it for a while, look at the technical document and look at what you've got and look at what was existing, and slowly it'll make sense as to how to connect it up. So that's the way I mounted the bracket for a Series 1 to get it to fit in there. I followed John Saunders' tip of doing 1 axis and driver at a time so that you don't get the wires or leads mixed up. Just having a look here at it. If you look on the bus board very closely, you can see there where my finger's pointing. See the X there? So that's the X power, and that's 302 and 30. This is a bit tricky to do with the camera, and 303, 302 and 303. So we've got the other 2 old drivers still all connected up with the wires. So our only other block that's free, that's been unplugged, is this one, 303 and 302. So that's obviously the X leads, and so they go into the terminal block that plugs into there for the X leads, and they're connected to the ground and the VDC, those 2 top terminals, just to make sure you don't get it muddled up. That's a safe way to do it. So you can connect those 3 wires that you've still got taped on the end of your X stepper motor lead. You can connect those up to the new terminal block, which is going to plug into there. Well, when I say ground, what I mean is PWR-GND. Let's just be literal about what's saying there. And the other connection is VDC. And the 3 phase wires going to the motor, the U, the V and the W. U is red, green is V, and W is yellow. So there's a little bit of a code thing going on here, so you need to concentrate. You might need to have a coffee before you do this, but so that's the first driver connected up. There's a little terminal block there with the main wires from the bus board, 303 at the top. Next one down, 302, then red, green and yellow. And if we look over on my other Tormach, you can see conveniently that's the same, 303, 302, red, green and yellow. So before I completely remove the first lead, which has got the 3 phase wires going to the stepper motor, you can see there's a 4th wire, and it's green and yellow. and I presume that's an earth, and if you follow it through, it connects up through to there, and I assume that's not required because it's not, that wire is not present with the new stepper motors or drivers. So I'm just going to disconnect it and double check John Saunders' YouTube video to make sure I haven't missed anything. So that's the first lead, the X lead removed. I just disconnected this, which looks like a ground wire. Had a look at John Saunders' video and he did the same. Thanks for the video, John. Yeah, YouTube videos are brilliant, aren't they? They lock in knowledge when people are up to speed with it so that others can benefit from it. Brilliant resource. Alright, well, it's all back together now. The main leads, power leads to the drivers are a bit short really, because it's so far forward with the adapter brackets, and it's not really allowing enough room to install the cable cover in that area because the wires are just too tight. So I've just cut that end of the cable cover off for now anyway. It's okay, it's just not quite as tidy as I'd like. But anyway, let's boot it up and see if it's all going. Alright, well, I've booted up the computer and typed admin configure into the MDI line and selected series 31100, powered up the machine. Let's have a wee peek inside. Okay, let's have a look at the drivers. Oh, I can see a problem there already. See, there's a little LED that shows that they're powered up. So that's the Z one's on, that's fine. But the X one is, but the Y one is not on. So it seems like there's no power getting to the Y driver, or it's a faulty driver or something. Oh dear. You always dread this, don't you? You finally get it all together and you hope you're going to be lucky and everything's going to work fine, but I'm not going to be lucky. So anyway, let's try the Z, because the light's on the Z. Yep, that's going. Let's try the Y. No, nothing. Well, there wouldn't be, there's no LED light on. Let's try the X. The X is going, but actually that's not going correctly, it's very slow. Something's not set up right, it's going less than half speed. Ah dear, I've got two faults. Fault with the X speed, and the Y driver seems to be dead. It's not going at all. I better investigate this a bit more and have a look at the troubleshooting section of the manual. I'll get back to you. So I've had a bit of a read through the troubleshooting section. Tormach do a really good job of this, don't they? And access drive subsystem checklist. Since there are at least 3 identical electronic driver modules in the access drive subsystem, swapping control signals between modules is very helpful during troubleshooting. So what I've done is connected up the working X-axis, well, it's sort of working, it's half working, to the Y driver, and you can see there's still no LED light on there, no green LED light on as there is here in the Z. I couldn't entirely swap them because with the Series 1 and the adapter brackets, the leads from the bus board are not long enough to allow a complete swap, but at least I could change over the semi-working Y inputs over to the faulty semi-working X inputs over to the faulty Y driver, and I'm still not getting a light there. The software seems to be working. If we look here at the software, that's the faulty Y, and that's operating. The X is operating and the Z is going obviously completely correctly because it's connected. So it does seem to be the major issue is we've got a fault with the Y driver. I guess I'll have to contact Tormach now. Oh dear. And just to confirm my suspicion that the Y driver is the problem, I've plugged the control signal and the power supply from the Y driver into the Z driver. So I'm now using the Z driver to power the Y axis, and it works fine. So the stepper mode is obviously okay, and the power supply is obviously okay. We've eliminated it down to the driver. So that's one of the issues. It looks like a replacement driver is the solution. I can swap it out from the driver in my other Tormach, but then that puts that one out of action. But I guess I should do that just to confirm it. So I robbed a driver out of my newer Tormach 1100, plugged it into the upgraded one, and the LED light came on straight away. So that's a problem, a dud driver. And just to confirm it here, if I operate the Y, it's going fine. So the Y is fine. Now if I replace the driver, I know the Y will be fine, the Z's fine, and the X is just about half speed. It's very quiet and slow. I don't know what that is. Something more subtle is wrong with the X. I just popped the cover off the driver just to see if I can see anything obviously wrong. Well, I'm not an electronics expert, but I noticed there's a little fuse there, and that looks like it's blown. It's got a funny burnt out look about it, and I've just done a continuity test across it, and there's no continuity through the fuse. So that's indicating a fault, but I don't know whether the fuse blew because of another fault within the driver, or whether the fuse has just got old and packed up and all I need to do is replace the fuse and all will be well. If I could get a fuse that size, I don't know. So that's the big problem with the Y-axis sorter. It's just sorted, it's just a faulty driver, just got a slow X-axis. I know what some of you experts will be thinking: are you sure you've got the dip switches set correctly? Well, I checked them about 3 times and on the 3 drivers, and I checked them for the 4th time, and I noticed I had the dip switches, one of them was wrong on the X-axis driver. Unbelievable. I checked it 3 times and they were fine. I don't know whether it's got a mind of its own or whether I've got a mind of my own. But anyway, flick the dip switch over the right way, and now that X-axis is fine. So we're getting there, we're getting there. We've just got a problem with the Y-axis driver. So we're down to one serious problem, which is just replacing the driver. So just a little update. I contacted Tormach and explained that one of the drivers was dead, and they air freighted me out a replacement immediately. So within a week I had the replacement driver here. Thanks very much, Tormach. Excellent service and customer support. So it's all up and running now, and I've got all 3 axes going fine and the Z brake going fine. Okay, let's put it through its paces. Z axis, up and down, X and Y, and finally the Z brake. So it's locked in place, it's not descending under its own weight. I don't need to use my safety block as a backup just in case anymore. Okay, so with the Series 3 and the little brake on the Z stepper, let's just go over quickly how that operates. There's three states that little disc brake canister can be in. Normally when the machine's not powered up, the springs are operating, pressing the little disc inside the canister, and the brake is on. And that is solely to stop the head from descending down under gravity. So it's held approximately in a stationary position. It's not a high precision hold, but it's a safety hold. When the machine's powered up, the solenoid operates, compresses the springs, and the brake is off. Now there's no need for a brake from now on because the stepper motor will hold the head in its position with the power of the stepper motor. And the third position is if you manually throw the little lever over, where are we? That little lever over, it cams over and compresses the springs and frees it up. And there are a few rare situations where you may need to do that, but not normally. So I've marked it with a felt pen in those two positions, a slight rotation of that little cam arm. So in its normal position, when the lever is in line with the x-axis, that is not affecting the brake, and the brake is free to operate either on or off. And when it's twisted a few degrees anti-clockwise to that off position, it is affecting the brake, and it's holding the brake off, so that you can rotate the Z screw if you want to when the power is off. For example, if you're working on the thrust bearings and so on. Okay, well I've just partially pulled the brake canister off the top of the old stepper motor so I can get a bit of an understanding of how it works. You've got to be a bit careful here. Tormach warned about this. There's just a very short piece of wire there. See if I can put a light on it. See it down there. And so if you wrenched it off a little bit roughly, you could strip that wire or damage that wire. So it's a fragile connection. There's no excess cable there. So I've just lifted it off a few millimeters so I can see the internals. So looking at the externals, there's a lever there with a couple of dimples on it. See the dimples there and there? And you can see them on the inside there. And they fit into little dimples on the top of the canister. So when you rotate that lever a few degrees, it rides up the dimples and you get a cam action, and it pulls that central pin or shaft, which presumably affects the internal brake. So I can't actually see the exact construction, but there's a solenoid, some springs, and a brake in there. And when the power is applied to the solenoid, it overpowers the springs and disconnects the brake. And when the power is not applied to the solenoid, the springs apply the brake. And so there's a mechanical clutch there between the slot and the flats in the shaft. So that plate there that's got a slot in it will be, that plate there will be rotating when the stepper motor is rotating, and that plate is the part that's braked either on or off. But that's just a bit of an overview of the construction. There was some talk in one of the forum threads recently that the new design Series 3 Z brake is a bit more sophisticated, and it comes on and off at various times during the operation of the machine. I don't think it does. I'm not an expert on this, but just looking at the way it's wired up, this relay or contactor is the switch. When the machine's powered on, the current runs through the fuse system and the bus board and into the solenoid, which releases the brake, and the position of the stepper motor is controlled solely by the steps in the stepper motor. And when the power is powered off the machine, the relay then switches it the other way. There's no longer any energy in the solenoid, and the springs operate, and the brake goes on, holding it in approximately the right position. And I think that's all that is happening. There are some changes to this Series 3 bus board, but I think those changes are just design changes to refine the circuit a little bit and improve its operation. If you're upgrading from a Series 2 to a Series 3, you may not need to change this little upgraded bus board, but because mine was a Series 1, I replaced that bus board. I did have a Z-brake on this very early machine and a bus board, but I fitted the one supplied because it is probably an improved circuit. That wraps it up, guys. Thanks for watching. A little bit of drama at the end. I can already see the advantage of having both my Tormach Series 3. I was able to swap out the driver and establish what exactly was faulty. So yeah, it's quite a big job doing the upgrade. I imagine there's quite a few people out there that are still running Series 1 and they're thinking, oh, will I do it, won't I do it? Well, it is quite a big job. I mean, unless you're an electrician and you're very familiar with this type of thing, if you're just an ordinary engineer like me, I'd put aside at least a day for it. It could well take up the best part of 2 days if you're going to do a bit of adjustments and you have to move it out from the wall as I have, and then you've got some teething troubles to troubleshoot. It could knock a hole in 2 days. It's quite a big project. Cheers.